Today I will be discussing about the gravitational lensing, what is gravitational lensing, and why we need to discuss gravitational lensing. And I will also discuss about the agenda. So let's start. Let me give you an overview about like what I will be discussing in this video. So I will be telling about you what is gravitational lensing, to the types of gravitational lensing, the famous examples and discoveries related to this, and then the experiments and the observations so far till date, and why we need to discuss this gravitational lensing, like why this matters. So I will be discussing all this thing. Okay, so let's begin. What if we told you that massive objects which are hidden in spaces act like magnifying glasses? Like really, if you pick any magnifying glass and you can like if you want to magnify anything, it will show you. The gravitational lensing acts like that, and it also bend light itself and reveals the hidden galaxies which are like far away from us, in terms of thousands of light years or billions of light years away. So we need to remember the key points. So who predicted the gravitational lensing? Einstein predicted this gravitational lensing, this phenomena, in 1915. And this gravitational lensing help us to understand or help us to see the galaxies which are invisible. Okay, so like with if gravitational lensing is not there, then we can't able to discover many galaxies. So that's where gravitational lensing helping us, and it also help us to understand the universe structure, the basic universe structure, and the dark matter also. Okay, so now what is gravitational lensing? So see, in physics, we have a Einstein general relativity. So what it means, so what it says, the general relativity says massive objects curve the space-time. So here the massive objects mean, like if I talk about our solar system, then we have Jupiter, we have our own sun. So these massive objects or the black hole itself also like curve space-time. So these things comes in general relativity. And then also light, the photons also follows the curved space-time, and they are also appear to bend. uh, Let me give you an example to understand better. Think of a bowling ball on a stretched rubber sheet. Uh, if you like rolls the marble, it follows the curved path around that ball. You will be seeing the video also. So exactly like that, the more the massive object, the stronger the lensing effect. Okay, and also we compare to glass lens, which bends light, but instead of glass, it's a fabric of space-time itself, which is being wrapped by gravity also. Okay, so I hope you understand about the concept of gravitational lensing here. Now I will be discussing about the types of gravitational lensing. So there are three types of gravitational lensing. One is strong, second is weak, and third is micro. So in strong lensing, it creates multiple images of the same background object, and it can form Einstein rings also. So Einstein rings are like perfect circles when alignment is exact, and it can also like magnifies objects to from around 10 to 100 times also. Examples of strong lensing will be cross of Einstein and horseshoe Einstein rings also. uh, then another example is weak lensing. Okay, so it's like slight distortions in galaxy shapes, and it's only detectable statistically around across like thousands of galaxies. So like if we have a pool of galaxies or cluster of galaxies, then it is like it is like a detectable but static, but like we need to like we need to look far into this. Okay, and this weak lensing is used to map the dark matter. Okay, so you can take it like suppose you are looking through a slightly wavy window. So in microlensing, when we have smaller objects like stars, the stars and planet itself acts as lenses to see the bigger picture, and it's create temporary brightness of background stars, and it's like used to discover exoplanets also, and the events also last days to months also. Okay. Now we move to the famous examples in gravitational lensing and discoveries also. So first of all, I will be talking about the historical examples, like in 1919, solar eclipse. Arthur Eddington's expedition like confirmed Einstein prediction. Then we have discovery of twin quasar. It's QO957 plus 561. So it's first time the gravitational lens discovered in 1979, and through Hubble telescope also through Hubble deep field it revealed lens galaxies from early universe. In the modern discoveries, if we talk about, it's like Abel 1689. It's like a galaxy cluster creating specular lensing. Then we have a cosmic horseshoe discovery. It's like uh, nearly perfectly Einstein ring. And if I talk about the record holders, as far as you guys, it's like highest magnification achieved over 1000x, most Einstein rings in one image. It's the record holder is Abel S1063, and you can see on the screen also, and the experiments and observations so far. So we have the current mission. So in the current missions, we have Hubble Space Telescope. It's like it detects also the incredible lensing image. Then we have Euclid mission, Wheeler Human Observatory, and we have James Webb Telescope also. And from the ground-based surveys, we have Dark Energy Survey. And Dark Energy Survey is focusing on mapping the cosmic structure. And then we have hyper stream camera. So it's like used for wide field to detect weak lensing surveys. The weak lensing surveys, I already talked about that. Like it's like slight distortions in the galaxy shapes. So why are we discussing about gravitational lensing? Okay, so if we talk about the scientific impact, uh, first of all, it matters because it maps the dark matter. Okay, it the lensing reveals the invisible matter which we can't able to predict or which we can't able to see. Then it helps to understand about the dark energy. It helps to understand the universe expansion also, and it also tells about the first ever galaxies formed, like the early universes which were made. And then it also tells about the exoplanet detection also. Like we have Earth, which is habitable, but it also helps in understanding the distant stars in different solar systems, another solar systems which are habitable to life, where like Earth-like conditions are there, and humans can live there and survive there. So it helps to understand uh, jet exoplanet also, and it also tests the general relativity. By the way, it confirms the Einstein predictions already. So yeah, and if I talk about the practical side, like the practical application, how it matters there, then it's like it improves our understanding of fundamental physics from 90s to today. And it also like helps us to locate and study the most distant objects in our universe. And the last thing, it provides a natural way of telescopes which are which are like more powerful than we have built. Like we have James Webb telescope, but it's like you can say 1000x better than that, the gravitational lensing. Okay, so in the end, I will conclude it by like gravitational lensing uh, turns the universe into a natural laboratory, and we are just like beginning to unlock the full potential of what human capabilities are, and how we can perceive the universes, and how the things are going on in that universes. And the universe itself is helping us to explore its deepest secrets. So yeah, so that's about the gravitational lensing, and I hope you have learned something about it, and feel free to share your feedback about gravitational lensing.